Hi, I'm Guo Cheng Guang, 11 years old, Primary 6 from YUMIN Primary School. So far, until this lesson in techniques of definite integral, what have we learned for the special functions? For that, we have already learned about gamma function and beta function. But with these two functions that we have already learned, we need to know how to use them in our integrations. So that is why we need to use these questions to let us know what types of methods do we have. For different questions, you have different methods. Let's look at what we have this time and what kind of methods would we need to use. So when you look at this question, this boundary, 0 to infinity, then in this integrand, you have four parts. You have an x squared, a square root x, e to the power of negative x, and a sine x. There are two parts in front in the index function. You can combine them into one part. Then you have an exponential, and then after that, a trigonometric function. But then for this, let's think of which of the function has this exponential. Well, obviously only that gamma function. This gamma function. We need to know what is its definition. Or gamma function, you write it like this. And let's say, for example, inside we have a p plus 1. Then for this, you'll integrate 0 to infinity. Okay, this boundary is the same. But later we'll need to see whether it is still the same. Then x to the power of p and e to the power of negative x dx. So this part, exponential e to the power of negative x. This part is very important. It must be a negative. So later we might need a little bit of substitution. But later we'll see whether we need or not. Exponential, then in front is this x to the power of something. Well, it can be anything, but right now, other than whole numbers that we know, we also know a half. So this is the gamma function, but then we have an extra trigonometric function here, the sine. The sine is there and makes it a little bit difficult, but we'll have a method for that. This will let you think of our Euler's formula. For this Euler's formula, firstly, e to the power, but it can be, let's say it's an ix. Then this would be equal to a cosine x. Then you have to plus I sine x. Then what if I add a negative in the power? E to the power of negative ix. Then this would be equal to cosine x minus I sine x. you see these two signs. The I. But wait. When you use this to minus, you could get a sine x. When you just use it to minus, cosine, you don't need to care about that since they will just cancel out. So use this part. Then, because there is an extra 2i, so you need to divide that 2i. Like this. So this is your sine. Now you get this sine, you can actually just put it inside. Okay. So let's start this. X squared and the square root x, combine them. And you'll get x to the power of 5 over 2. But this exponential part, it stays there. Sine x, sub in that Euler's formula. Then you'll get something like this. When you see more of these e's, you can't just put them in one integration. You have to separate them. Okay. But this 1 over 2i will just leave it in front. First term, 0 to infinity, x to the power of 5 over 2, you can just leave it there. But now there's a problem. Do we write I minus 1 or do we write negative 1 minus I? Because we want to make it simple, and in that definition we need a negative. So that is why we'll put a negative 1 minus I. Then here's the x and dx. Then the part at the back, you have to minus 1 over 2i. Then you integrate from 0 to infinity. X to the power of 5 over 2 times e to the power. Both of them are negative. We'll just take that out. 1 plus I x, then dx, like this. After that, these parts, we need to make them just an x. So that is when we start to use our substitution. So we'll use our substitution now. For this part, let me write it below. This might not be enough space. I'll just write it in front, at the side. So let 1 minus I, then times x, be equal to u. But because we have the x to the power of 5 over 2 in front, so we'll need to know what is x. Just divide is u over 1 minus I. Then you have to know dx. Since you need to change it into u, so that dx you also need to change it into du. So differentiate. Become du over 1 minus I. But you also have to know its boundary. U, where is it from? To where? So when this is a 0, u obviously 0. Then this one need to be all the way to x. When it's an infinity, well, u will have to be infinity, like this, for the first part. Then the second part, whereas now it's a 1 plus I. So we can let this 1 plus I x be equal to v. X would be equal to v over 1 plus I. Then dx, it will be dv over 1 plus I, and v is from 0 to infinity. Am I right? Okay. The first part, 1 over 2I, you can let it stay there. Then, okay, still integrate from 0 to infinity. X to the power of 5 over 2. Put this in. So, numerator, u to the power of 5 over 2. Denominator, bracket 1 minus I to the power of 5 over 2. The exponential part, 1 minus ix is a u, so it's to the power of negative u. But then dx, when changing to du, you have an extra over 1 minus I, like this. Then minus 1 over 2I. They have to, okay, still integrate from 0 to infinity. X now is for the part with v. So it's v to the power of 5 over 2 over bracket 1 plus I to the power of 5 over 2. Then e to the power of that. So it will become e to the power of negative v. They have to times dv over, okay, so it's this part, over 1 plus I, like this. Then maybe we'll go combine these two. These two will combine. So then it will be equal to 1 over 2I. For this first part, it would be 1 minus I, then just to the power of 7 over 2. When you don't look at these two parts, you'll realize, wait, isn't it in the same form? Except that this is to the power of 5 over 2, okay, plus a 1, 7 over 2, then minus 1 over 2. Let's see for this part. Combine those. Still to the power of 7 over 2, but it's just that it's a 1 plus I. There. V to the power of 5 over 2, e to the power of negative v. Same boundary. So it would also become gamma 7 over 2. When it becomes like this, two of the same thing, you factorize them out. When you factorize these two out, would you also like to bring along the 2i? Well, we can bring along that 2i. But maybe let it stay inside first. Like this. Then this part, we can make it into 5 over 2 times 3 over 2 times a half, then times that square root pi, because at last it becomes gamma half. And that we have found out is square root pi. Then for this, we can just common denominator. But then you see, if we just straight away times these two, but we can take one and another, put them together. So they become like this. Then a minus b, a plus b, a squared minus b squared. 1 minus negative 1 is a 2. So this will be a 2 to the power of 7 over 2. Then for the power, this part 1 plus I, then is to the power of 7 over 2. Then minus this 1 minus I to the power of 7 over 2. Okay. Then after that, at this part, denominator those twos, we can put them together. This, we can take out 3 whole 2's. That means it's 2 to the power of 3. Then to the power of 4, 5, 6, 7. So 2 to the power of 7 is a 128. Well, at the numerator, you have a 15. But how about the other square root 2? Well, I'll put it with that square root pi. So the square root pi over 2. Therefore, this I is still here. But then at this part, it's a little bit tricky to solve that. But we can take out a square root 1 plus I, a square root 1 plus I, so that it will be equal to, maybe let's try to take out, wait, let's first think, can we use anything from here? The only thing I see is that you can use this part. This is for the front, then the negative for the back. So for this, cosine x and sine x, they can be both 1 over square root 2. Yes, that's it, 1 over square root 2. So we have something like this. Then, this part in front, put it outside. Then at this part, at first, e to the power of, so square root 2, you'll need pi over 4. E to the power of pi over 4i. But then, there's another square root. And that will make it a pi over 8i. Like this. Then there's the negative, just add a negative here. So, there will be a 4th root 2. Wait, not so fast. It's not just like that. You also have to get it. Here is a 7 over 2, but this is already a half. So you need to the power of 7. When you need another to the power of 7, this part will become 2 to the power of 7 over 4. Like this. Then inside there. For the first term, this also need to the power of 7. E to the power of 7 pi over 8 I. minus, just add another negative there in the power, 7 pi over 8i. Now what can you see here? Minus. Isn't it similar to this? Just that you can put a 2 out here, but then you have to simplify another 2. So that means you will have to lose 4. So divided by 4, 32. Then square root pi over 2. Here is 2 to the power of 3 over 4. Over. Okay. Then you'll be a 2i. 2i. Maybe you just want to straight away change it into that. Straight away change it into this. In this case, the x is a 7 pi over 8. So it's a sine 7 pi over 8. Like this. After that, these parts, let it be the same first. Sine 7 pi over 8. Let's look at this. 7 pi over 8. It is in the second quadrant. Let's change it to the first quadrant. Pi minus that. Still the same. Sine pi over 8. Like this. Then this would be equal to 15 over 32. But this part, we know sine pi over 4, cosine pi over 4, but then pi over 8. Wait a second. Pi over 8, pi over 4. Let's use that. You can call it the double angle or the half angle formula. So this sine pi over 8, that would be equal to square root 1 minus, okay, since this is a sine, so it's a minus. Then it's a cosine pi over 4. Cosine pi over 4, 1 over square root 2, then over 2. Then we can both numerator and denominator times 2. And this whole thing square root. Both times 2, then this will become a 4. Then it goes out. This, an extra 2, becomes a square root 2. But then inside, it seems like that we still can continue to simplify. A square root 2 at most. So, a fourth root 2. Then inside will become, here's a square root 2 minus 1. Wait, fourth root, and this becomes a 2, then a half, that disappears. Wait, let me just see. Okay. But this part in the denominator, it seems annoying. We don't like that in the denominator. So let's just times the 2 here. Then in the denominator, there will be an extra 2. Then you can make it simplify. Then when you make it simplify, it will become a square root 2 pi. Square root, let's just put that together. So it will become a square root 2, then bracket, square root 2 minus 1, bracket, pi. Then this would become a very simple answer. Let's take a look at these methods that we have used. Well, very importantly, this gamma function and Euler's formula. Euler's formula. Seems like that we have used a lot of times. One time, then is expansion, separation, gamma function. After that, just factorization. Common denominator. Wait, this part. We use another time of Euler's formula. 2 times already. Another time. 3 times. There are no more. But we also used the double angle formula, or otherwise known as half angle formula. Then simplify and combine. So it's like this. And also, another very important thing, substitution. So in this lesson, are you clear so far? Now, I think we can end here. So we'll see you in the next lesson. And if you like our videos, don't forget to subscribe to our channel. See you in the next lesson. And thank you for your watching.